Hi everyone, today I will be presenting PatentScore multi-dimension framework for evaluating LLM-generated patent claims. I'm Yongmin Yu from Macquarie University, Sydney, Australia. Patent claims are not just a technical text, they are legally binding document. So our work asks, how can we evaluate LLM-generated claims in a way that truly aligns with expert judgment? Patent claims are taught to evaluate. They are structurally complex with dependencies across elements. There are also legal tasks, so every word matters. And the stakes are very high litigation. But existing analogy metrics like a BLEU or ROUGE only check surface similarity of fluency. They complexly miss the structural and legal aspects. That makes them unsuitable for the patent. Traditional metrics often give high scores when wording is similar, but they ignore error like broken reference or vague scope. However, experts penalize those mistakes very heavily. As a result, we found the negative correlations between BLEW, ROUGE, and expert ratings, so new approach is clearly needed. The key challenges are twofold. First, structural complexity. Claims must maintain strict antecedents, biases, and logical dependencies. One mistake can invalidate the entire claim. Second, balancing technical accuracy with legal defensibility. Too broad or vague, and the claim is legally weak. Too narrow, and it loses its value. Existing metrics cannot capture this balance. Our solution is PatentScore. It's a multi-dimension framework that combines structural accuracy, legal defensibility, and semantic one. It is grounded in the WIPO patent drafting manual and designed to reflect how experts actually evaluate claims. PatentScore have three dimensions like as you guys see that such structure dimensions, legal dimension, and semantic dimensions as well. The first dimension is a structure. We check whether claims follow proper format, use punctuation correctly, and maintain antecedents biases consistency. Even a small error here can make claim invalid. The second dimension is law. We check elements of referencing, logical validity, and whether the scope is ambiguous. For example, about 10 volts sounds very fine in plain English, but legally it's a very vague one. So there's two dimensions turn out to be the most important for aligning with expert. The last dimension is the semantics. We use a BERTScore to comparing meaning between generated and reference claims. It helps capture technical context, but comparing to the structure and law, its contribution is smaller. Experts care more about precision and defensibility than about surface level similarity. We tested 400 patents from HUPD dataset, GPT-4 mini generated claim first, and 3 experts evaluated them. One expert is a legal specialist, and 2 technical experts who are holding a PhD degrees. PatentScore show excellent alignment with expert. It achieved a correlation of 0.819 with expert ratings, while BELEU and ROUGE had a negative correlations. Error rate also much lower, and results generalization well across other LLMs like Claude and Gemini. So PatentScore is reliable and broadly acceptable. Our evaluation studies confirm that structure and law matter most. Removing those metrics drop performance by around 10%. Removing semantics barely changes result. So experts strongly value structure correctness and legal precision, while semantic similarity plays on a secondary role. And there's still limitations. The dataset is restricted, certain field and years. We also focuses on the intrinsic aspect, not novelty or prior art. In future work, we plan to expand the dataset, novelty check, and then integrated legal knowledge graph for the factual validation. To conclude, PatentScore is the first framework that brings together structural, law, and semantics for evaluating LLM-generated claims. It aligns with expert judgment, outperforms traditional metrics, and generalizations across models. The main takeaway is that structure and law matter most in patent far more than the surface similarity. Thank you very much.